Wow, I'm crazy. Wow. Just in case, guys, I have another similar video in my channel. Okay, I teach in the spring 2022 or another semester. I can send to you that video. Okay, this video, okay, it's a half. Well, it's not half. It's one fraction. Yeah. I saying wait, no problem. I saying another point. Get the same example. I never change. Well, I change, not frequently. Okay, suppose the example trick is more interesting. Nobody remind me recording. I suppose I recording at the beginning, no? Or no? Maybe I remember, but another class I teach before this. Okay. Suppose in the example 3 I want to find the complicated thing. I have one sequence in which the term a to a in the position 8 is 75. And in the position 20 is 39. Wow, this is weird, ¿no? Entonces nada, where's the goal? The question is find a sub m expression. I have no idea. To find this, I need a1, I need d. And after that, well, that's it. Let me see. Yeah, that's it. That's it. Okay, that's it. So in this case, it's not giving clear who's the first and who is the complex. Okay? This is the most complicated scenario, no? But you don't worry, it's too easy. Look, I tell you my famous formula. What formula? That formula. A sub m in any position is equal to a1 plus a minus 1d. Okay, professor, but I have no a1 and no d. Okay, I understand. But we can apply the formula. Suppose that a sub 8 is given in the problem que 75 is equal to a1, que I don't know, plus 75 minus 1, que is 74. It's not 75, no. It's 8, and it's 8. Sorry. 8 minus 1 gets 7. 70. Do you follow me, guy? So I copy a to 8 is equal to a1 plus a minus 1d, because we are working the position a, no? Okay, this is 7, but this I know the giving information que a to a is 7. Do you understand this equation? I want to call equation 1. Now likewise, a20 is 39, que is equal to a1 again plus something, que is 20 minus 1, que is 19, and this is my equation 2. Cool? And we have two equations, 1 and 2, and we have two unknown, que is a1 and d. Okay, let's do it. So something is weird in this sequence because a to a is 75, and when you're moving forward, you get a 20, we have 39. Now my sequence is decreasing, it's going down, no? Since it's going down, it's because I predict the common difference negative number. That is a reason of subtracting and decreasing. Makes sense, right? Okay. No problem. We're focusing now in this system of equations. Let me recopy again. 75 is equal to a1 plus 70, equation 1, and 39 is equal to a1 plus 19D. There are many ways. You are strong doing this job. Suppose that you subtracting equation 1, elimination maybe. Subtracting equation 1 minus equation 2. Subtracting this is 36, no? No. Is 36, no? A ver, 15, carry the 1, yeah, 36. 75 minus 39, 36. That part is cancelled. And that part, no. That part is negative. Negative 12. I guess so. Because 19 minus 7 is 12, but it's negative, no? Because you are subtracting the equation 1 minus equation. Either way, guys, you subtract 2 minus 1, it doesn't matter. But I subtract the 1 minus 2 because I suppose that 75 is a bigger number, no? So to get positive here, it's okay. D. Finally, divided by negative 12, both sides. 36 divided by 12 is 3, but actually it's negative 3, so D is negative. And this is exactly we predict that the common difference is negative because our sequence is decreasing, it's going down. It's because the common difference is negative. In order to find A1 that we need for the equation, we plug it in, for example, in the equation 1, que is 75, is equal to A1, que I have no idea who is that, plus 7 times negative 3, que es D. Entonces 75 is equal to A1 minus 21. Minus or minus, no? Es minus, yeah, es minus. Therefore, A1 is 75 plus 21 is isolated. It's the 96. 96 is A1. Okay, so I found 96, negative 3. But what is my formula? My explicit formula. Well, my explicit formula is just plugging in. Plugging in here. A sub m for any position is equal to 96 plus a minus 1 multiplication by negative 3. Entonces now you distribute it is minus 3m plus 3, no? Yeah. A sub n is 99, que es 96 plus 3 minus 3. Boom. My famous formula. Okay. One, you check it. For example, for n equal 1 is 99 minus 3 is 96. And you check it, for example, in the position 8. In the position 8 is position 8. This is double checking to make sure that we are doing well or not. 99 minus 3 times 8, no? Is 99 minus 24. 99 minus 24. I put it in my calculator now. It's 75. Cool. Checking this. And the position 20 is 99 minus 3 times 20. No, 3 times 20 is 60. And 99 minus 60 is 39. Cool. Exactly like that. Any question, guys? Do you understand this problem? Arithmetic sequence. So this is the most complicated scenario. Okay, we have so you have the first guy and the common difference. Everything is okay. And so you have two intermediate. So now you apply the formula 2 times in order to find the first and the common difference. And when you have this in your hand, you set out the formula and you can compute everything you want. Okay. That's it, no. The most important part is now, if you have, for example, summation. Let me go over here. Summation. Again, we apply the summation symbol from k equal 1 to m of the a sub n. And this a sub n this arithmetic sequence well, we have formula. We have a formula, and the formula is a special formula. I can prove, not necessary proof. It's easy to remember. Is you adding A1, que es the first, plus AM, que es the element in the last position of the limited, divided by 2 is like an average of this, a multiplication by M. Actually, look, it's easy to remember. You have A1, A2, A3, bam, 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 plus AM. You adding this guy plus this guy. You average, adding and divided by 2. A multiplication by the M. It's very, very similar, remember? And the other property we studied, get a 1 plus 2 plus 3 plus 2, M. You adding M plus 1, so the first and the last, multiplication by M and divided by 2. This is the particular example. Okay, in this case is the arithmetic sequence, and the common difference one. But in this formula, do not participate deep. Magically happen que do not participate. Okay. Let's see example. A ver, I bring 1, 2, and 3 examples of the summation. Let's do it. Suppose, compute that. This is a typical example of the test. Compute that. 60 plus 64 plus 68 plus 72 plus 2. I don't know, but following the same sequence. And the last guy is 120. Compute that. And first of all, I need to discover si es arithmetic sequence or no. You're subtracting this and this, F4. Subtracting this and this, F4. Subtracting this and this, F4. Enough. D4. D4. And the formula for the summation say summation for k equal 1 to m a sub m. Let me call summation m. This is equivalent to this. Do not repeat again the summation notation. You put capital S sub m. This is the style you use in the book. Actually, we're doing summation. Well, summation for any is the first guy I have in my hand, okay, 60, plus the last guy I have in my hand, okay, 120, divided by 2, or average, both multiplication by n. It's a formula. Look at that. I copy a little bit different, but it's the same. Yeah, I copy simple. You apply the order of operation, you adding, divided by 2, and multiplication by n. You adding, divided by 2, and multiplication by n is the same. So basically, is you adding 60 plus 120 divided by 2 and multiplication, but I don't know how many times is m. M times, in this summation, I don't know. How you find that? Easy. Easy because I know the complementary formula is a sub m is equal to a sub 1 plus n minus 1 d. I know that a sub n is the last one, I suppose, because I want the position m here, is 120. The first guy is 60. M is exactly the same I am looking for, and therefore, and so for n. It's super easy. You're subtracting 120 minus 60 divided by 4. Well, let me use in the calculator. Well, 120 minus 60 is 60. And 60 divided by 4 is 15. And 15 is equal to m minus 1. Therefore, so you solve for m, 15 plus 1 is 16. Actually, this summation is from 1, in this specific example, from 1 to 16. So now the formula is super easy. It's 60 plus 120 divided by 2 and multiplication by 60. Done. The answer is 1440. Okay, important. Do you understand very well or no? Remember, basically, we have only two formulas. That formula, super important. That formula, super important. Because this formula gives me the position. And this is summation. Okay? Let's practice. I bring two examples I consider interesting of the summation in arithmetic. Suppose this example. Compute that. So the question say compute or find the sum. Find the sum. Sum of what? 4 plus 4.5. Wow, decimal. Plus 5 plus 5.5 plus I don't know, but I suppose que dot indicate to 100. Okay. Well, I suppose que arithmetic sequence because we are studying in this section arithmetic, but on the test you don't know. See, this arithmetic or another sequence that we study after this. And then to say you try. You compute the hypothetical common difference. Subtracting. It's over the 4.5 minus 4.5. 5 minus 4.5. 5.5 minus 0.5. The common difference is 0.5. Okay? And they want you to find the summation. Summation sub m. The formula is you add in the first, get 4. You add in the last, get 100. Divided by 2 and multiplication by n, I don't have idea who is n, because this summation is n times. I need to find the position for this 100 and the sequence. And this increasing, but increasing too slow. So I suppose it's very long, the sequence. No? I suppose, I don't know. And the formula complementary is a sub m is equal to a1 plus a minus 1 d. A sub n is 100. A1 is the first guy, get 4. N is exactly, I don't know, I need to find, and d is 0.5. So 100 minus 4 divided by 0.5 is equal to n minus 1. So 100 minus 4 divided by 0.5 is 192. Therefore, n is 192 plus 1. It's 192. Wow, too long sequence. And the position 193 is 100. Okay. And we finish, no? No. We finish now when you compute the summation of the 193 element in this sequence. Get 4 plus 100, first and last, divided by 2. Multiplication by 190. And the answer is 10,036. Guys, as always happened with me, in the review package, we go over again to this topic, no? More specific, similar as the example you can see in the test. One more for the arithmetic sequence. One more. Look. Suppose we have this computer. 8 plus A1/4, wow, mixed number, plus A1/2, plus A3/4, plus 9, plus plus 50. Okay, let me try to investigate as arithmetic sequence. You're subtracting this guy minus this guy is over the 1/4. This guy minus this guy, it's a little bit complicated. No, it's not complicated. It's A1/2 minus A1/4. You're subtracting the whole part, it's 0. A minus A. And subtracting the fraction part is 1/2 minus 1/4. The least common denominator 4. You have 2 minus 1 is 1/4. It's exactly the same one. It's a one possibility. Another possibility, the student that don't like this way, bueno, you put in the calculator. Oh no. Look, you convert to the from mixed number to a improper fraction. Okay, it's easy. Your multiplication is 16, 17 over 2. You understand where I come from 17? 2 times A is 16 plus 1. Minus is a 33, no? 33 over 4, no? Because it's 32 plus 1. 32 plus 1. Yeah. Okay, now again we find the LCD, the 4. So we have 4 divided by 2 is 2 times 17. 17 times 2 is 34, I guess so, no? 34. Minus 33 and 1/4. Again, repetition, the same. No problema. Do you understand very well the fractions? I suppose you know. Right? Likewise, I propose you, I encourage you to investigate what's going on. So you continue subtracting this minus this, and this minus this is 1/2. This is my common difference. Now my common difference is positive. It's a small number. That means that our sequence increasing, go up, but slow down. Okay? Entonces now they want to do the summation. The summation, the formula is A sub m S, capital S, sub m is equal A1, que is 8, AM is the last 50, divided by 2, and multiplication by m. The problem is to find m. How many elements we have in this sequence? I have no idea. Let me try. The complementary formula is A sub m is equal to A1 plus n minus 1 d. In our specific example, A sub n is 50. A1 is 8, is the first guy in the sequence. And I have no idea, but D is 1/4. 1/4. You prefer decimal fractions. You prefer decimal 0.25. It's a fraction 1/4. And so now you isolate and instead of division of multiplication. So F50 minus A. 50 minus A. Multiplication by 4. Get 42. No? 42 is equal a minus 1 divided by 4. No? Therefore, cross multiply. No? 42 times 4 is 168. Is equal to m minus 1. Finally, m is 169. No? Because it was 168 plus 1. And we discover that in this summation we have 169 elements. The summation is 169. Is equal A plus 50 divided by 2 and everything multiplied by 169. And the answer is 4,901. Boom. Final answer. It's easy, eh? And always don't do anything by hand. Using calculator, please. Okay. And the rest of the time, we have 15 minutes, I want to explain another kind of sequence. It's super important, extremely important. Extremely important. And you see again with the teacher in Calc 2 is geometry sequence. Geometry sequence. Geometry sequence is, for example, let me see example. It's example in which, for example, you have 2, 4, 8, 16, 32, and so, and use, for example, you subtract because you believe que es arithmetic sequence. You subtract 4 minus 2 is 2. 8 minus 4 is 4. No common difference. However, we have common ratio. Common ratio. What means ratio? Ratio is division. Common ratio. Common ratio. And you divide, no subtraction. You divide 4 divided by 2 is 2. You divide 8 divided by 4 is 2. 16 divided by 2 by 8, sorry, is 2. And 32 divided by 2 is 2. Okay? And so we have no common difference. We have common ratio. Ratio means division. You divide any element divided by previous, and the answer is the same number. Que in this example is 2, pero no necesariamente 2 en any example. Es, en general, es 2 o es 3 o es fraction, even it's a negative number, si es decreasing. Entonces, what is the formula? What is the explicit formula for finding any element in our geometric sequence? It's A1 again, multiplication by common ratio raised to the n minus 1. It's a formula. Esa formula is analogous to the formula that we're using in the arithmetic. It was A1 plus n minus 1, que es de complementary, ¿no? D. But no this anymore, que es common ratio. Suppose I want to find in this specific example the explicit formula to generate any element of this sequence. Okay, no problem. A sub n is equal to A1, que es the first guy, que es 2. Look at that. This is A1. Multiplication by the common ratio, que the common ratio was 2 also, no? A divided by, I erased that part. The common ratio was 2. You see before, right? This is 2. It's 2 raised to the n minus 1. And you leave it like that, you can. Oh, why not? There are no reason to have 2 numbers, because this is the same base separately. And you want, so you leave it like that, it's okay. It's 2. The exponent here is 1, and 1 plus n minus 1 is a sub. And this is logical, because for n equal 1 is 2, for n equal 2 is 2 squared is 4, n equal 3 is 3 squared is 8, and 2 to the 4th power is 16, and 2 to the 5th power is 32, and so on. Okay? Super clear? Okay, it's a formula. I suppose I want to complicate your life, no? Because I am a complicated guy, no? I'll leave my wife say that, I am complicated guys. Suppose we have this example. 10, 9, 81 over 10, 729 over 100. Bam, 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 bam. Entonces, my goal is, number 1, proof que this sequence is geometric or not. And secondly, find the A sub n explicit formula, and why not compute any position, que es the position 9. Okay, so question number 1, proof que es geometric. Question number 2 is compute the general formula. and compute the position 9. The number is weird, but you don't be scared for this. So you, first of all, need to prove it's geometric. To prove it's geometric is too easy. You divide. You divide this divided by this. It's 9 divided by 10. Okay? You leave it like that if you want. Or not. Or you put it in the calculator. When you put it in the calculator, it's 0.9. In this. Okay. And now you divide this divided by this. It's 81 over 10. Remember, any element divided by a previous. It's not. You want by hand or calculator, either way. By hand. 9 is a whole number. So I suppose get 9 over 1. So it's 81 over 10. Get the fraction on the top. I copy exactly the same and flip it because of division. This. Entonces 81 divided by 9 is 9. So you get simplification a little bit. Divided by 9 is 1. Divided by 9 is 9. Again, we have 9 over 10. And I encourage you that you try to do the next exercise. Don't complicate your life with the fraction because you put in a calculator and that's it. Okay, you put in a calculator, suppose 0.81 divided by 10 is divided by 10 is super easy because it's 8.1. So you move the 81 is a whole number. I suppose get the decimal point here. Divided by 10, moving to the left one decimal point. You put in the calculator like that, divided by 9. Let me try. You put in my calculator 8.1 decimal divided by 9. 8.9. And that's it. Exactly the same of this without complication. Let me try this. This is is 729 divided by 100 divided by 8100 over 10. This is crazy. No, it's not crazy. Look, it's 7.29 divided by 8.1, right? Because you have 100, you move the decimal point one place, 1, 2, and this is 1. And you put in the calculator one more time. It's 7.29 division 8.1. Boom. Again, 0.9. We discovered, fantastic, no problema. This is the geometric sequence because it has common ratio. And by the way, the common ratio is 0.9 or 9 over 10, the way you prefer, fraction or this. It's equivalent. And that's it. No. This is just the beginning, coño. Now I need to find A sub n. The formula is A1 R n minus 1. Esa es formula. Pero A1 es 10. Entonces A sub n formula is 10. And R is, suppose que I prefer, in the paper I prefer fraction, I don't know. It's 9 over 10 raised to the n minus 1. Or 10 0.9 raised to the n minus 1. Either way. This way, people can like decimal using this second way. The student can don't like decimal and like fraction using this way. Okay? Or that way. The whiteboard fixes the shape to a square or circle because I set out for this intention. Okay. Now, what about a to the 9 power? The 9 power, no. The position 9. So what is the element? You need to compute the element located at the position 9. Plug it in. It's 10, 0.9 raised to the 8 power, no? Because it's 9 minus 1, 8 power. Okay, let me try using another calculator. I put 10. Okay, there you go. What's going on? Oh, I need to change the button. Well, I have different calculator. I have that calculator. Case 10, parentheses, 0.9, power 8. I got it, which is weird. It's 4.304671. It is. Okay. Okay. Cool. You have a question or no? No? Okay. Now I want to introduce, because it's a little bit complicated. We'll continue next time. The summation and the geometric sequence. Because let me try to use intuition. Intuition. No, intuition. The formulas. The formula. What is the formula for the summation? What is the formula for the summation and the geometric sequence? S sub m. Exactly S sub m that we studied in arithmetic. Remember, is A1 plus AM divided by 2, multiplication by m, is the summation in arithmetic. Sequence. And what is the formula in the geometric? Alright, different. It's a little bit more complicated. It's A1. So we have fraction. In the top of the fraction, we have 1 minus Rm. And the bottom of the fraction, we have 1 minus R. Parentheses here or no. You complete this fraction first and multiplication by A1. Let me see one elementary example. One very, very elementary example. Suppose that we have this fraction. 1 over 2, this summation, sorry. 1 over 4, 1 over 8, bam, and this is 1/2 to the n power. Those n equal 1 is 1/2, n equal 4 is 4, and so on. Okay, so this is super clear. Okay, A1 in this example is a motivation example. I want to explain in detail next time. This A1 is 1/2. Is the first one. Look, and the common ratio is 1 over 4 divided by 1/2. It's obvious that 1 over 4 times 2 over 1. Okay, 2 over 4, okay, then it's 1. And it's matching perfectly with this formula, no? Because it's, it's 1/2 to the first power is 1/2. And 1/2 to the second power is 1 over 4, and so on. No? And the formula, remember, is in the complementary formula for this is A sub m is equal to A1 R n minus 1. In this specific example, A sub 1 is 1/2. And common ratio, by coincidence, is also 1/2. Look at that. n minus 1. So when you multiply this and this together, it's obvious that it's 1/2. This is 1/2 to the 1 power, and n minus 1 is 1/2 to the n. And give me exactly the intuition that I predict here. Okay? Let me try. In the time that we have, guess not too much. Apply this formula in this specific example. Suppose they want to compute S and 3. S and 3 means that you are in the first 3 elements, this plus this. Suppose I do it by hand, no formula. Well, the least common denominator is obvious, is A. A divided by 2 is 4 times 1 is 4. A divided by 4s2 times 1s2, and A divided by A1 times 1 over. This is 6 per 1, 7 over. So 7 over 8. I did by hand. Suppose que I want to use in the formula. What formula? That formula. In that formula we have Sn3, because n I suppose que is 3. A1 gets 1/2. Multiplication by 1 minus 1/2, get the common ratio, raised to the cubic power, divided by 1 minus 1/2. Because in this example, repeat again, A1 is 1/2 and common ratio is 1/2. Well, this is elementary. I want to analyze after complicate. So today elementary. So we have 1/2 here in outside. We have 1 over 8 is 1 minus 1 over 8 divided by 1 minus 1/2 get 1/2. And so 1 minus 1 over 8 is obvious que 7 over 8. Because in my mind, 1 is like A over 8. Eh? The A minus 1 is 7. Wow, and this 1/2 it cancels and it stays the same value. Okay, guys, don't worry for this. Again, in the next class, I want to repeat again the summation for the geometric and some specific, particular, complicated examples of this. But so far, it's okay. Okay? Okay, let me, do you see my face now? Okay, good attendance today. I copy the name. Sebastian, Natalie, Christy, Marlon, Lizzie, Krista, Jose, Joanne, Christian, Ryan, Ken, Cooper, Kenny Cooper. Okay, guys. Have a nice, good afternoon. And we see next movie. Thank you, thank you, thank you. Thank you, Desiree. Bye-bye, guys.